The term control or consistency is often used in generative AI, not just because we humans are obsessed with control, but because we want to feel like we are part of the image or video generation process. Whether it is converting a sketch into a render, changing the style of a photograph, or exploring different design options, control plays a key role. And today, we will be exploring that through a concept called ControlNet. This is not limited only to the field of architecture or interior design like you see on your screens. We can use it for various design fields as well. For instance, in this particular case, I wanted to convert this car into different options of design. So I could mask it, change what it would look like into different materials or colors. Or in this case, I wanted to change how this particular suit looks like. So I changed its color, I changed its fabric, and also changed its material. Or you can also use it in product design. For example, let's say in this case, I have this watch. I masked this out and now I made it a little bit wacky. I added like a thunderstorm into the dial, or I made it into this colorful dial or this robust concrete dial. So the limitations of ControlNet is endless and it depends on your imagination. Hi everyone, I am Kedar, and today in this video we will dive deep into understanding one of my favorite concepts of generative AI, that is ControlNet. But before we begin, I wanted to thank you all because we just crossed 100 subscribers, closing towards 150, and this is really crazy to me. I started this YouTube channel 2 months back, and I'm learning on a daily basis how to edit video, how to write scripts, how to make myself talk better. It's not really natural to me talking on a camera, but I'm getting better. And let's see in my post-production if I can add confetti to show my happiness about how I feel about 100 subscribers. But your support means a lot and I really appreciate it. So thank you. And let's get into the video about ControlNet now. So what exactly is ControlNet? The first time the word or the ControlNet for any particular trained model was developed was in this particular research paper, which is about adding conditional control to text to image diffusion model. Now the version 1 of this paper came in Feb 2023. This is a snippet from the version 3, which was from November 2023. And let's see what they say ControlNet is about. So they say ControlNet allows user to add conditions like canny, human pose, etc. to control the image generation of large pre-trained diffusion model. So what it basically is trying to say, basically large pre-trained diffusion model we all know right now, they could be stable diffusion, HDXL, flux or anything. What they are saying by adding conditions, for example, in this first case, let's say you wanted to add a image of a deer and get the almost same deer into different, here in this case is different seasons. So what you do, you tell generative AI, in this case we'll be looking at ComfyUI, that okay, using canny, understand the edge of this particular deer, and then you prompt it. Then you might say, like they have said here, masterpiece of fairy tale, giant deer and golden antlers. So here you get different iterations of the same design because AI understands its line drawing basically through a ControlNet called canny. Then there is another one which is called human pose. So for example, let's say this particular person, you extract the pose of it into this skeleton kind of drawing. Now you can replicate the same pose by changing your prompt. So here they are saying chef in a kitchen, and then you get two chefs with the similar pose, or Lincoln statue, again the Abraham Lincoln statue with the same particular pose. So that's what ControlNet does. And basically that's what they're saying, which is adding conditions. And there are not only two ControlNets, there are a lot of ControlNet. So in the same paper, if you go down, I think it's a very interesting paper if you want to read. These are few of the ControlNets that they talk about. The first one is simple, called sketch, which basically converts any of your input into a black and white line drawing like a sketch. The second one is called a normal map. This depends on, or rather creates a 3-dimensional map depending upon where the light is falling. For instance, here in this teddy bear example, is it a teddy bear? Let's call it a teddy bear. You see that near where it is like pink magenta, it has more light versus near its nose. And then you can see the subsequent images also have that lighting style. Now, depth is quite simple. Whatever is closer to me looks white and whatever is far looks black. And then you get subsequent images. And then Canny, we already looked at, which is understanding the edge of any particular object. It could be a photograph, it could be a render, it could be a sketch, anything, and it creates iterations from it. Then the next two, you might be wondering, they also look the same like Canny. LSD is basically called as a line segmentation detection. Now the difference between Canny and LSD is LSD works with lines. So it could be straight line or angle line, doesn't really work with curved forms. So that's why I generally like to use Canny, because as a parametric designer, I always like to work with curved designs, and the Canny helps. Then you have something called as HED, which is basically called as, okay, I had to see what is the full form of this, which is called as holistically nested edge detection. So basically what it does, it takes any of your image and converts it into kind of a sketch with varying line thicknesses. So the way we draw, we don't draw it directly line to same thickness. Some has a small thickness, some have a bigger thickness. This I think is good for products, but not really good for architecture or interior, because if you can imagine a building, you can't have a slab that's like thick here and then goes all the way and becomes thin. So that's not really helpful. And then you have something called as segmentation, which basically what it does, if you have a photograph, it segments into different color codes or parts depending upon how the model is trained. And then you can tell AI, okay, whatever is red color, or let's say whatever is doors, change those, or whatever is windows, change those. So this kind of is understanding the color coding. And the last one is human pose. So you put your particular any image, it detects, gives you a skeleton out of it, and the next iteration follows that same particular pose. And there has been a lot of progress with ControlNet. These are not only those, with human pose also now they have something related to face with hands, because you know AI struggle with hands. So to get exact fingers or exact facial expression, you have ControlNet related to that as well. But in this particular paper, we have only these particulars selected because it was again in 2023. It's wild how the time gets warped in Gen AI. This is just 2 years old, but it feels so old right now that it feels ancient, because there are models coming on every day and it's wild, you know. But anyway, two of my favorite ControlNets that I use, and I think it will be helpful for most of the designers, which we'll also see in this particular video, is Depth and Canny. Because if I understand the outline of particular design and I see that what is in the foreground and the background, I will be able to create a similar looking 3-dimensional or a 3D image. Now let's look at how this is actually working, or how it is trained, because I think it's important to understand what happens in the backend, even if it is little bit. So this snippet is from the same paper, but the version 1 that came out, like I said, in Feb 2023. Now here they're saying ControlNet is a neural network architecture. That is fine, that's obviously understood. That is trained to learn task-specific input conditions. For example, maybe it's like a Canny or Depth or whatever. The ControlNet, now they're telling you how this ControlNet models are really trained. The ControlNet clones the weight of a large diffusion model into a trainable copy and a locked copy. So whatever you have a base model, maybe it is HD or HDXL or Flux, they make two parts, one that is a locked and one that is a trainable copy. The locked copy preserves the network capability learned from billions of images, while the trained copy is trained on task-specific dataset to learn the conditional control. Whatever is a locked copy remains as it is. So the lakhs of images in that particular model remain as it is. In the second, or in the new one, which is the trainable copy, they change it to the ControlNet that they want. So basically all of these hundreds and lakhs of images are converted into a line drawing if they're training a Canny model. And then the trainable and locked neural network blocks are connected with an unique type of convolution layer called zero convolution. And this is a little bit jargon of words, where the convolution weights progressively grow from 0 to optimized parameter in a learned manner. Since the production ready weights are preserved, the training is robust at data sets of different scale. Since the zero convolution does not add new noise to the deep features, the training is as fast as fine-tuning a model compared to training new layers from scratch. Now, what are they actually trying to say? So I kind of made a chart to explain this in a better way. Basically what's happening, so you have your base model, which could be, like I said, HDXL or HD or Flux. It is not the fine-tuned model, which could be Realistic Vision or Juggernaut. Those are fine-tuned models. They take the base model. Then in the step 2, they separate it into two parts. One that's a frozen model and the other one that's a trainable copy. Then what they do, they add any specific control net that they want. What they are establishing or making a code so that the lakhs of images are converted directly into that particular control net. For example, here in this case, we're looking at Sydney Opera House. See, in that data set, they convert this into a depth map. Now you have two sets, one that's a frozen and one that is a new changed controlled set. But the model doesn't know this because they're two separate. So that's where they apply the zero convolution layer, where it learns how the control input relate to the original image. Because the model has to learn that, okay, I have this line drawing or I have this depth, but what is the relation of this to this original image? So this is not happen because there are two separate sets, and that's where zero convolution comes. It learns or understands the relationship between the changed to a specific control net and the original data set. Okay, I think that's basically what it means. And then you get your model. So now you get your canny model, depth model, because now it is trained using zero convolution. And why they say zero? Because it starts from nothing. So it's trying to understand relationship without having any knowledge. Otherwise, like they say, it might have changed anything in the original data set. So to avoid that, they start from zero because it doesn't know anything, and then train it progressively to understand, okay, what is the relationship between this locked and this new changed data set. And then we get the trained control net model. Now that could be a canny model, it could be your depth model, any particular model. So that's the trained model. Now, when we use this in the ComfyUI workflow, we also need to add a preprocessor, because what this does, it converts that image for that particular model to understand. Because this particular model, let's say they have been trained on human pose, but suddenly if I add my image, it's not going to understand what pose I have. So I need to convert my photo into a human pose, like a skeleton drawing, so that the model understands that, okay, this is my data set which is already trained on human poses, and now this is the new particular new pose from which I can then make the image generation. It's kind of easy when we do the workflow, but that's what is the entire process of how this control net models are trained and how they will work. Okay, so let's look at what changes we need to do in the ComfyUI workflow. We looked at this base workflow in previous two videos, where you basically add your checkpoint model. This could be fine-tuned model, doesn't matter. Then you add your positive negative prompt. Then you add your image resolution and quantity, basically what is the size of the image and how many images. All of this goes into case sampler, it gets decoded, and then we get the generated image. As simple as that. Now, where the control net part comes, it comes something like this. Now your prompts don't go to case sampler directly. They go through control net, because this is the new condition that the AI needs to follow and generate the image, and not really just generate from what the prompt is. So the prompt really needs to go through the control net, and you can also stack the control net. So you can use canny plus depth plus human pose. Doesn't matter. It doesn't have to be only one. You can use multiple control nets, and we'll see that how to do. And so, like I was saying, there are multiple control nets. For example, the same Sydney Opera House, I can convert that into a depth or a canny, which is the two model that I generally use. And then you end up with these design options, where you can change how much of the input do you really want, how much of the prompt you want, because when we are actually doing this process, we will be negotiating between whether you want the 100% of the control net or 100% of the prompt, or you want more of the prompt, less of the control net, and things like that. Now let's look at the evolution of control net, because things are happening so rapidly. It's crazy in the world of Gen AI these days. Especially the last 2 weeks has been ridiculous, and there have been 2 new models, and I have been thinking about control net over and over again, but we'll look at that as well in the later video. The control net 1 was introduced, like I said, in Feb 2023, which was the paper. Then for control net union, now what they did, they kind of stacked all the control net. So basically, you have a canny control net for understanding the line, which is around, let's say, 700 MB. Then you have a depth control net, which is again around 700 MB. Then human pose and things like that. So what they did, they kind of made a giant burger, combining all of those into one, and it's called as a control net union. So all you need to do, take this model because it has all the trained control nets in it. Of course, you have to use the preprocessor with this, and that came out in July 2024. Then we had the control net union for Flux, October 2024, and a couple of 3-4 months back we got in March Flux control net union Pro 2. But the two models that I use, or the two controllers that I use, is the HDXL, which is what we will look at today. I did try these two. I didn't really find it. It was so also when I download any model, I'm also looking for speed and output. While the Flux ControlNet 1 and these are good, they tend to slow down my computer. So that's another reason why I avoid those. So two of my favorite ControlNets right now is HDXL, which is what we'll look at, and then Flux ControlNet, which we'll look in the future video when I talk about Flux, and that came out in March 2025. Now let's look at what things look like when you use a Canny ControlNet. So I'm going to use the same example that we had or done in the last video, which we made like a simple minimal surface from Grasshopper, took an image of it. So when you apply a Canny ControlNet, it detects the outline. And what happens in the outcome, it only emphasizes on the outline because it doesn't understand anything else. And with any ControlNet you use, you will need to change the strength. For example, in this case, strength is 1, which means kind of use this 100%. You can also increase the strength or decrease the strength. And the prompt remains, I have kept the prompt same in the future slides as well, which is aerial view of a wooden pavilion in the jungle with humans underneath, Unreal Engine render at golden hour. Now you see, with Canny, you only get the line drawing. And if I reduce the strength, now I made the strength 0.75, you get very little, only 2 lines, but the image is not really understanding what the input image is. When I decrease it further to 0.75, you hardly see anything of the original image. And if I reduce it more further, there is no influence of the original image at all. But on the contrary, if I use only a depth ControlNet, here things change. So what happens is AI understands what is in the foreground and what is in the background. So there is a direct influence of this particular image in particular output. So you see, you can see the same image in the same and almost close looking output. Again, the prompt is the same. But the same thing, if you decrease the strength value, then it will go away from the original image. So now it's going to get squashed with 0.75 strength. It gets further squashed. So you can imagine that it's only taking one of the curves. This could be this base interior curve and little bit of this outline curve. And if I reduce it more, it's not going to take anything. It's just doing its own random pavilion in the jungle. What I generally like to do, I use both of them together, which I have found to give the best results. So in this case, you see, I have used Canny plus depth, but when you make the strength 1 and 1, you're going to get something really absurd or something that's not looking exactly correct. What you need to do when you use both of these ControlNets, because what AI is now understanding that, okay, I need to use 100% of Canny and 100% of depth. So it uses the ControlNet so much that it deviates from the input image. What I generally do, I change the strength of them to, let's say, 0.75, and you get this nice looking image which has the line drawing. So you see, from this Canny, it has now captured the line drawing. The edges are crisp and also has a depth to it. So that's what I do. And it's not necessary that the strength of the both need to be same value. For example, let's say you want depth to be more. So you can keep depth 0.9 and Canny can be 0.4. This ratio is up to you, or depends on the image, and that will come with permutation and combinations. Then if I reduce this further, now you see I made the strength 0.5. Still it's not changing because this is a combination of both ControlNet. But if I change it less or if I decrease further, then you will hardly see any of the input images. So in brief, always I like to use Canny plus depth and not make the strength 1 for both of them. If I use both of them, I reduce it slightly. Generally, I keep depth less than Canny if I want the edge to be profound, or if I want the depth to be more, I keep depth more than Canny. I rarely keep both of them same. This is just for you to see when they have the same strengths. Now, with the ControlNet node, you get something called as a start and end %. With any of the ControlNet that you will use, you get a start and end %. This is what the node will look like. So like I said, the prompt goes through this particular node. So you add your positive and negative prompt. Then you add your ControlNet, whichever you are using ControlNet model. And then this image is the image that comes from preprocessor. Okay. We will do the full process in detail. I'm just telling you what the model looks like. And then you have something called as a strength. And below that, you have a start and an end point. end percentage. What this means, so let's say this is the 100% of how much the AI needs to use the ControlNet. Now you can tell AI that, okay, only use the beginning 50% of the ControlNet, remaining you do whatever you want. Or you can say, first you do your part and then use my ControlNet. Okay. So now here you see the start percent, end percent is same. Is this above this or is this same line? Okay, I don't know, my OCD just kicks in randomly, but ignore me. So if I keep the strength same, 0 and 1, you're going to get throughout. Now when I reduce the end percentage, you will see the output changes a little bit. If I make this 0.5, now you will see it has taken the edges but not precisely. It now has breaking the edges because it has taken only the first 50% and then the rest 50% is doing on its own. So this is very helpful when sometimes what happens is that you don't want the 100% because sometimes with ControlNet 100% gives something really off. So you can make this generally 0.9 or 0.8. The lesser you go, it will kind of deform your original input. Now if I go less than that, you see it's like hardly nothing related to the input image. It has kind of, I think, taken this particular curve and you have this particular curve. Apart from that, nothing really. So this is with the end percent. Similarly we can change the start percent. Okay, I don't advise to changing the start percent because you will see what happens. So what this means, you are telling AI, okay, in the beginning 25% do whatever you want, then take influence from canny and depth, and you see it has done any kind of random pavilion and now it's only giving me a outline. So I don't recommend to start with any percentage, always keep it 0. Then if I increase it further, you will only see like a thin line. If I increase it further, you don't see the line at all. My ideal configuration for start and end percent is I keep the start percent 0 so that it takes the entire control in the beginning, and the end I sometimes keep on changing to, let's say, that 0.8 to 1. This I found to be the good value to get a better result. Okay, so I hope it's clear how ControlNet kind of works. The base understanding, even if you understand, it's good enough. Now let's look at what do we need to install. So the first thing that you need to do, open Comfy or ComfyUI app, then go to Manager. We installed Manager a few videos back. When you click on Manager, then you go to this first one, which is called Custom Nodes Manager. So click on this. Then in the search bar, you need to type ComfyUI ControlNet Aux and install this. Then it will ask you to restart Comfy. Then RG3 you might have already installed. Then install something called as Comfy Role Studio. Why this is helpful? Because there is one node here called multi-ControlNet, which will allow us to stack ControlNet on one top of each other. Do not install all of these together. First install one, restart Comfy. Install second, restart Comfy. Install third, restart Comfy. Okay, so this we are installing, so we get all the ControlNet preprocessors. Now we need to install ControlNet models as well. So again, go back to Manager. Now this time go to Model Manager. Click on Model Manager, and here in the search bar you can just type ControlNet. So and then you can download either you want. So it will ask you two options: rank 1 to 8 and rank 256. So basically, rank 1 to 8 is faster but gives less detailed result. Rank 256 is slower but gives more detailed result. I prefer rank 256. So you can install and see to it that it is SDXL. So you can literally install what I am installing right now. So I have installed Canny, I have installed Depth, I have installed Recolor, I have installed Sketch, I have installed OpenPose, and I have installed QR Code Monster. So just to see all these ControlNets again, like I said, you can take a photograph. It could be anything. The imagination is up to you. So I took this as my old photograph. And now here I'm using Canny ControlNet and I convert this into an architecture. And how amazing is this? You see, it has converted my glasses into this kind of, I don't know, what do you call it, 2 blocks. And even you see how the blocks are shaped like my glasses. It's completely wild. I get like carried away with ControlNet and I have to stop myself using ControlNet because with Gen AI, we are bombarded with so many images that seeing one nice looking image makes me feel really amazing. So this is what Canny looks like. So basically converting into a line drawing, and then you can convert into anything that you want. Then coming to Depth, Now here somehow not a lot of things of my face have been converted into depth, but you see the influence of it in the output. It's kind of converted this house into like it has a helmet, and then there is like these ears protruding, kind of just like converting a helmet into an architecture form. But looks really nice. The influence of my image is being carried forward. Then the sketch one, which kind of makes this into a sketch. I think I used a scribble model for this. But anyway, you will see my like the checkered pattern on my shirt has been carried forward into these wooden logs. Even my collar gets into this kind of a curved line. So it's absolutely wild. Then I used a human pose. This is with the face. So it understands like, okay, this is my shoulder, and then my eyes are here. This is my nose, my lips and teeth. But it's not really getting carried forward in architecture because I had to reduce it. Otherwise, it was making a human architecture, and I didn't want that. So I had to reduce this, but it kind of, you will see that there is like this threshold here, and then the form kind of little bit follows. So this is what human pose does. And then lastly, you have something called as QR code monster, which basically takes your image and converts it into anything you want. It kind of, I don't know how to explain this QR code monster. The way it was done, so we have these barcodes. And if you want to convert these barcodes into like it's in the mountains, so you might have seen logos. So I remember early a version of this where you had like a Nike logo, and people were making this into like the logo is on the mountain, the logo is in the water, the logo is inside a building. So this is what QR monster does. So it takes whatever your image is, and now you see it's kind of converted this into an architectural space, and I love it. I absolutely love playing with ControlNet. And you see the details that are carried forward. And this is not even upscaling. I'm not even upscaling. This is the base image that I am just converting into any kind of form. And it looks beautiful. I can go on and on appreciating ControlNet. It's ridiculous. Anyway. So this is the first step that you have to do. You have to install all of those. First one, go to custom nodes manager and then install the models. The second step that you have to do, whichever image you select, we have to resize it. Because as you remember, HDXL works with 1024 by 1024 image. So if you give something like, let's say 4000 by 4000 pixels, it might take a lot of time, but also it might not really do a good job. So what you need to do, whichever image you decide, right click on that image, and then go to properties. Then here go to details, and here you will see the resolution of the image. In this case, this particular image was 2912 by 1632, which is too big to render. It will take a lot of time, and sometimes might not even do a good job. So what I do is I double click on the image. There are nodes in Comfy where you can resize it, but I still prefer this method. So what you need to do, double click on any of the image, and then you see this 3 dots, click on those 3 dots, then here click on resize image, click on this, and then you will be greeted with this window. Here it will show you what is the resolution and of the width and the height of the image. Change the highest resolution. For example, if this is a vertical image, change the vertical height. If it's a landscape image, change the width. If it is vertical, change the height. And generally I like to keep the max. So change whatever you like. I like to keep max 1440. I don't go above this. This is way enough. We can always upscale it. But for this, I generally like to go to 1440. And it does amazing job. So I don't think you need to go further than that. Okay. So 2 steps, download the model and whichever image you want, resize it. Now let's see what to do in ComfyUI. So this is the blank canvas. So first let's look at the preprocessors. So when you install or when you download from custom node manager, then you will see a lot of things. Now when I double click on the canvas, I can simply type Canny. So this allows you to get Canny preprocessor. So I generally like to use the first one, which is just a simple Canny preprocessor. Now this, as you see, has simple one image input and an image output. Okay, let's look at what we get. So I will take load image. So this is the image that I want to use as a ControlNet. So I connect image to image, and first let's see what output do we get. And then I'm just going to take a wire from it and see preview image because I don't want to save it. Okay. Now the first time you might run any of the preprocessors, it might download something. So don't worry if it's not running. You can always check in the log by this panel, and here you will see that something is starting to download. So if it is downloading, do not worry, it takes 5 to 10 minutes with every preprocessor. Okay, now if I run this, you see it converts me into a line drawing, right? Amazing. How amazing is this? And what are these two values, the low threshold and the high threshold? So if you, in simple terms, if you decrease this number, you will get more details in the image. And if I increase this number, I will get less detail. For example, let's say I keep the high threshold to 1 or 0.9 and the low threshold to 0.8. And then I run this. And then you see the details is reduced than the earlier one. Or if I want more details, I can reduce this value. So I can say make the low threshold 0.1 and make the high threshold 0.2, and then I will run it. And now you see there are so many lines. Okay, you have to remember that all of these lines will be influenced in your output. So this number is crucial the way you will get the output, and you will understand quickly like what number to use. I don't have any particular rule of thumb to use this particular change these values because it depends on the image. So if I only have, let's say, something that has a line drawing, I keep this high. But if I, let's say, sometimes use something like my photograph, then I keep it like 0.5 or 0.6 because I don't want all of these leaves and trees and my teeth. See how amazing my teeth are also here. Okay, so this value you have to keep on changing. So that's the Canny preprocessor. Then now let's look at depth. So if you double click on the canvas and type depth, you will see multiple Zoe depth. I use something called as Midjourney depth, which I have found to be quick and concise. This is the Midjourney depth, and here also you have image output and an image input and image output. So I'm just going to connect this image here and this particular output to this preview image. Here there are 3 particular parameters. I will keep this same right now and then run. Okay, and you see it has converted me into a depth map. Basically, like I said, the things that are closer become white in color and things that are away become black in color. Let's see if I change the resolution. Okay, you see with the increased resolution, it will start adding more details because now it is matching to my original resolution. So it's important to change this resolution number depending on the input image you have, because the preprocessors work with SD, XD, XL as well. So you need to specify what is the resolution of your image. Now I can go more. Let's see if it works. I think it gives error if I go more than this. So I have typed like 1440, it takes 1472. So you see now more details are being seen from my image. So the more you increase or the more you get closer to the input resolution of your image, the more details you will see. That is as simple as that. I don't really touch these first two. Let's check what happens. So let's say I make this one. Yeah. And you see hardly anything has changed. So I don't really change the first two. I only change the resolution depending on the resolution that I input. Okay. So that's the Canny and the depth preprocessor. Now let's see some other ones. You have something called as open pose. So this one, open pose, which basically again has a couple of parameters. The resolution, again, you change it to whatever image you have. And then here you have whether you want to detect hand, like I was telling you, the fingers, whether you want to detect body or detect face. Generally, I keep all of these 3 enabled unless I don't want something. For example, let's say I wanted to take an image of myself, a standing pose, and convert it into an architectural form. In that case, I off my face because then those minute details of eyes and all are really pointless to get in converting it into an architecture. Then I only take the body, so it only understands my skeleton. So let me connect this image here. Let's connect the image output here, and let's see what we get from this. Okay, amazing. It has converted me into this open pose where this is my shoulder line, this is my neck, this is like all these dots are eyes, nose, lips, things like that. Okay. Then QR Monster, there is really no preprocessor to it, and you can also try Scribble. So there's something called as Scribble lines. Again, the same. You only need to change the resolution here. So for example, I change here it to 1024, enter, and then I connect it to output, and then let's run this, and then I get into the Scribble. Damn, it's making me like a rabbit. My teeth are so pronounced in this outputs. But anyway, so these are all the control nets that you can use, and there are more. I stick to these two, the Canny and the Midjourney one. Mostly it suffices for a lot of architectural, interior, any kind of design work. Okay. Now let's see how does this integrate into the workflow. So this is only the preprocessor. We haven't added the model yet. So I'm going to clear this canvas. This was just to show you how this looks like. Then let's take the default workflow. So always go to workflow, go to browse templates, and then image generation. Okay, so this is the first one. So the first thing always to take is load image. Okay, so again, let me go to desktop. Let me take my face itself for this time. So this is the load image. Now from the same that we did the previous video, we need to use this as the new resolution of the image. So what we need to do is we need to delete empty latent image. Then from the image we say VAE encode. From this VAE we take a VAE, and this thing goes to latent. Okay, so that's what we did in the last video, and then we only change the denoise. Now let's see where the ControlNet comes in. So if you double click on your canvas and type ControlNet, you need to take something called as apply ControlNet, because this will help you apply ControlNet as it is. Now this is what I was telling you. It has 5 inputs. One is the positive, negative, what is the ControlNet, what is the image, and VAE. I had not added VAE in my presentation because this one already the model has baked VAE, which is this Realistic Vision version 4. So that's why I like to take baked VAE. Let's set up the ControlNet first, and then let's see where to add it. Like I said, if you don't know where things goes, you can always drag a wire. And now here it says ControlNet loader, which we take ControlNet loader. And here let's say I take Canny. So this is the Canny ControlNet. And now we need to feed this an image that the ControlNet understands. So we need the Canny preprocessor. So I double click, I type Canny. It's simple. Whatever ControlNet you do, double click on the canvas and use the same image. So then my image or my face goes into Canny. Okay, and you can always use preview image. So what I like to do, I use a preview image, and then this goes to image. That's it. Then we need to connect the positive. So the positive goes to this positive. Be careful where the positive and the negative go. And then the negative, then the positive goes from here to here. Okay. I'm going to speed this part up, which is me just changing the wires. Okay. So this is what it looks like. Right now it looks messy, but it's fine. I want to first test if it is really working, and then we will see what it looks like. Okay. So you need to adjust your prompt the way what you want it to look like. For example, I want my face to look like a modernist building made of curves, let's say. So you can adjust whatever prompt. You can go as wild as possible. That's what I tell generally whenever I teach anywhere. I tell with Gen AI, you have this capabilities in your hands right now to go as wild and bonkers as possible. Okay, don't quote me for this. Okay, so I just added a simple prompt, elevation of a modern concrete residence on the moon, and let's see what it does. And we have the output. And how cool is this? How cool is this? Okay, we have to change some parameters. Of course, I didn't change any of the parameters. You see my head has a moon and this, but still I like it. Now once you feel like everything is working, then you start tweaking parameters. Okay, so and now we haven't added depth yet. So that's why this image looks quite flat. Okay. So what I like to do generally, the strength, let's say we keep it like, let's say 0.6. The start and end, let's say keep it to 0.95. Okay. And then this one, let's add more to it. Let's say 0.2. Let's say this one is 0.2 and this one is 0.4. Okay, and now let's run this again and see what we get. So this is up to you. You need to keep on changing this to get a better output. Okay, and how amazing is this output? Look at it. It is amazing. It kind of looks like me in those Mount Rushmore figures. Amazing. Absolutely love it. So you can keep on changing, and now it's only taking Canny. So let's see how we add different ControlNets as well. So there are two methods. Either so what I generally like to do now, I like to group things. So this is working. So I say this as Canny. So I understand that okay, this is kind of for Canny preprocessor. Then I keep this here. Now this has to go through. So every time you add a new ControlNet, your prompt has to go through that particular ControlNet. For instance, now here it is going through Canny. Now if I add depth, then it has to go through depth as well. So let's see how to do that. I'm going to copy the same group, Now here I want depth, so I'm going to change this to depth. And then for depth, we know already I had taken Midas depth map. Here you only need to change the resolution and then connect this to preview image, connect this to the image, delete this one. There are two methods, that's why I'm doing this quickly to show you what is the how to do both of the methods. So positive goes to positive, negative goes to negative. Then we group this. Now this is the depth map. So let me put this here, and then now this has to go to my K sampler. So this now goes to the positive and this one now goes to the negative. Super simple, very, very simple. Okay, now here we need to add the image. So my same image, whatever my pose, amazing, reroute it and use the same image. Okay, so you have to use the same image. It can't be from the Canny preprocessor because this is already converting into a line drawing. So whatever is your load image, you need to add it here. Now let's say the strength is 0.6. I will increase it to 0.8 and let's see what happens. Okay, then what I like to do, this looks quite messy. So I group this also. So this is how then the workflow evolves. Now let's run this. Okay, and then you see what it has done. This is very, very off than what I needed. Okay, but this is what you will also end up getting. So what you need to do, then you need to change this. So let's say I want depth very less. Let's say I want only 0.5. And also you have to change the parameter, the prompt as well. Okay, so I'm going to change the prompt. I'm going to change a couple of parameters and then let's see what output we get. Okay, so then I changed a couple of parameters. I also added RG3 and now you see this is the output that we get. It is a bit silly, but I understand it's a bit silly, but I'm not like you need to keep on changing a lot of parameters for it to look better. But you see it does what it asks for. You take an image or photograph or a sketch, it will take the conditions from ControlNet and convert it into a new, totally new, amazing looking form. Now, once the setup is done, so the setup is ready, then you can only change the image. So what I do is, let's say then I add this sketch. All I need to do is I need to change the prompt. So first, always change the prompt. Then you need to adjust these parameters, which is the strength. In Canny, you need to adjust what is the low and the high. And then here you again need to adjust these parameters. That's mostly it. Okay. Now this is one way of doing it. The second way of doing is when we use a multi-stack component, where this is two separate things. But rather than doing that, we can stack controlnets one on top of each other. So let me show you that as well. Okay. So just double click on canvas, type controlnet, and here you see CR multi controlnet stack, which is coming from Comfy role node that we installed. So we need to take this one. And the way this works, it's kind of combining multiple controlnets into one. So in this case, you have image 1, 2 and 3. So you can input 3 controlnets at one. The first one is basically toggle whether you want it on or off. So let's say I keep it on. Then you have the same thing, whether you want it to, what is the name, what is the controlnet model. So the first one, I'll keep it Canny. Then what is the strength? Then what is the start and the end percent? Very similar to what we had in this particular apply controlnet. The second one also I will on. In this case, I add depth. So what basically this node is doing, it is removing the hassle of having these two and streamlining the process. That's basically it. If you're happy with this, you can go with this as well. What I will do is I will make a copy of this and I will bypass this. So I drag everything again and I say Control B. So this is off. Now let's edit with a new script. Okay, Control C, Control V. Don't get anxious about the script. Once you understand the process of what goes where, it's really simple. It's really, really simple. I've seen a lot of people get carried away with like, oh no, how are we going to do this script? It's really easy. I don't know, maybe because I learned Grasshopper before this seems much more easier. But the logic remains the same. Okay. So now let's see where this one goes. So we don't need apply controlnet. I'm going to delete this one. We don't need apply controlnet. I'm going to delete this one. We don't need load or controlnet model. We don't need this load controlnet model. But we do need the preprocessors. So the Canny now goes to image 1 because for 1, I have put Canny. Okay. So this has to be in sync. So if you use 1 as depth, add depth here. Then the Midas goes to 2. Okay. And now I'm going to fast forward and make things better. Okay, so this looks better, but here there is no input of prompt. Where do we add prompt? So again, if you type multi, so the first one is called multi ControlNet stack, and then you have something called as apply. You see CR apply multi ControlNet. This one has what is the positive, what is the negative, and the stack. So connect the ControlNet stack to stack, and you of course need to on this. And now this goes here. So your positive prompt goes to base positive, negative prompt goes to negative. I need to open this. Negative prompt goes to negative, and then this positive goes here, this negative goes here. So rather than doing that process, we can do this process as well. But for this, you need to install Comfy role node. Okay, then I will group this. So this is what it will look like. And isn't this nicer by using Comfy role custom node where you can stack control nets? Okay, now I am adding the sketch and I want to convert this into a render. So I'm going to change my prompt. Okay, so I'm changing the prompt now, and now let's see what happens. Okay, I might have to change this value of the depth and all of that as well here. So control net strength, I will keep it as 0.8, and this one depth, I will keep it as 0.6 because it's just a sketch. So higher value is always better. Now let's run this and let's look at the output. Okay, and it looks amazing. Okay, it looks amazing. It has followed the sketch, and you see how bare bones this sketch is, but it has done a great job. I told it to make it in a Scandinavian country in the night, and it has added human figures, trees. This is without upscaling. Okay, one thing here that I missed to do is that I had to change this canny values. You see here, this has not been able to do this line, so that's why the output is not profound. What I had to do is I need to change this. So let's say I make this 0.1, I make this 0.2. We'll make one more image, but you understand the concept. You get the depth, and in this case, I think we can increase the depth a little bit, and then I will run it again. And let's look at this output. Oof, this is amazing. Okay, this is amazing. I added like a moonlight, and you see now it's added people in the balconies and the terrace. How amazing it is, you know. And yeah, so that's what ControlNet kind of does. You take any image, it could be a photograph, it could be a sketch, it could be absolutely anything, and it makes this into an amazing render, or amazing however you wanted to visualize it. And like I showed you, it's not limited only to architecture or interior design. You can do absolutely anything, but because I come from architecture background, I know how to use those keywords. Okay, the next concept I wanted to show you is masking. Because let's say there's only particular part in an image which you want to change. For example, the car example or the watch example. Let's see how masking really works. But this is really good. Really good. Damn. Okay. So I will change the image. This particular workflow remains the same. I will change the image to this particular watch. Okay, that I already had. What you need to do to mask in Comfy, you right click on that image and you will say open in mask editor. Here you have brush types on the top right hand side. Either you can take a square or a circle, and what is the thickness and the opacity of it. I generally only play with the thickness. So then you can just drag wherever you want it. It's very simple. You just drag it. Be as precise as possible. I'm just doing very quickly. There is another way of using segmentation and doing this, but then again we got to install multiple nodes for it. So right now this actually works. Okay, you can zoom in, and then I can make this material, this thickness less, take a little bit of this extra watch loop in it, and then zoom out. And then this looks good. And then I say save. Okay, but if I directly connect this, we haven't used the mask feature of this particular load image. So you see, load image has two outputs. One is image and one is mask. So we got to introduce this mask in this workflow. So if you drag a wire, you will see there is something called as set latent noise mask. Take this component, super simple. It has one more input called samples. So whatever is latent, okay, you see color, match the color. So the latent kind of goes to sample here. And now if I connect this to latent, which is going through this reroute, it is going to use my mask. So if you have to use a mask, just use this particular wire. If you don't want to use a mask, directly connect the VAE encode to this reroute. If you want to use the mask, connect the set latent noise mask to reroute. Super simple. And then you have to change the prompt as well. Of course, always remember to change the prompt and all those parameters. So just give me a second and let's see what the output looks like. So now let's see how this output came. So I just told you to make like a carbon fiber watch with stainless steel dials and all that. Let me swipe this with the black bracelet. And amazing, how amazing it is. You see, it has tried to add the carbon fiber texture to the dial. It has made these hands stainless steel and made the bracelet into black. Amazing. And how quickly can you do this? It's mind blowing. Okay, so this is with the masking feature, because now you see the rest of the hand remains the same. I only masked the watch and I get only changed to the mask. Amazing. I don't know. Okay, I don't know. I get carried away with Gen AI, man. It's like ridiculous. Okay, and then the last concept with this is a hack. It's a complete hack that I am like, okay, this is illegal to do. But so, for example, let's say you have a particular photograph. You wanted to convert bits of it to something else, but you want to also retain the photograph. Okay, let me tell you what I am talking about. This, I call it as a denoise hack. So whatever is the workflow, whatever it could be the workflow, you can only change the denoise parameter and the output changes. Okay. For example, here in this particular case, let me take the laser. Now here in this particular case with denoise 1, you get this, whatever, this same image is converted. But as I reduce this value, you will see it goes towards the original image. Now, why is this helpful? Let me go forward. Now you see, I love these kind of representations where my original design is as it is, but here it has added human figures and trees. This is such a powerful way of representing your work. And if I go less, you see now there's only humans. So with denoise, what it's actually doing, if you remember from our previous, my previous video, with denoise, it goes back to the image, but now because you're applying ControlNet, it retains the original design. And this to me is super powerful. Okay, let's see an example of this. For example, what I will do is I will change this image. So I'm gonna choose an image, and let's say I choose this grass with 2 rocks, and I want to convert this into an architectural space. Okay, I'm going to prompt the same. I'm going to just copy this particular prompt. No, I need to type it again. Okay, so just give me a moment till I change the parameters. Okay, so I changed the prompt. Now you need to change the denoise value. So if it goes towards 0, you will get your input image. If it goes to 1, it will get completely new image. What I do, I think a good range is between 0.5 to 0.75. So let's start with 0.6, and this you have to keep iterating. There's no other option. So let's see with 0.6 what we get. Now let's see the output. Let me scroll over it. And you see, it has taken the influence of the image. Right now it's not doing exactly what I wanted it to do. But I can see that there is an influence of it. So which means I need to increase the denoise value. So let's say now I make this denoise value as 0.7 and then look at what we get. And now let's look at the output. Okay, so let me zoom in. And I love it. I absolutely love it. You see how it has maintained the 2 stones and converted that into an architecture, and it's retained so much of this original image but still added that prompt. And this is really an hack. I'll tell you, this is an hack. I use it a lot of times, and this is, again, we are not upscaling it. This is the original image. So you only need to change the denoise value. Everything remains the same. So we looked at 3 processes basically. The first one was kind of just adding ControlNet with any preprocessor you want. That could be Canny, Dep, OpenPose, anything that you want. And to use multiple, you got to stack them one on. You got to use multi ControlNet stack. On them, select the preprocessor, select the model, and then see to it that the same preprocessor goes to same image. Then we looked at masking. So you can drag. You can only select any particular portion, and then when you use mask, change this set latent noise mask. This goes to your latent image. If you're not using mask, directly let VAE encode goes to the latent. And this is what the workflow looks like. Super simple, and always keep changing the prompt. and keep changing these parameters. That could be your for canny, that could be how much ever line weight you want. For depth, it would be resolution of your image, and for this one, how much strength of the ControlNet you want, and whether you want to start and end fully. Generally, don't change the start value, change the end value to 0.8 or 0.9 and you get a good result. Okay, and these are some of the use cases which I have explored with just changing the denoise value. For example, in this first image, I made this kind of a illustration mountain image, and then I changed the denoise value, and you see how beautiful these images are. They retain the original, they didn't retain the illustration style because I didn't add in the prompt, but they retain the characteristics of the mountain or where the position is and the water body that was. So here I think the denoise value was around 0.7. Or in this particular second image where I changed the denoise value to get this more cohesive kind of output. And you see it kind of retained the same style of the original image. So by just adding, of course you need to add ControlNet. There's no masking here. It's just changing the denoise value, which I think is a hack really. Then there are a couple of other examples. So then I took this amazing image of frog, and I wanted to see what architecture looks like. Similarly with my face, now this kind of converts that into a different architectural style using ControlNet and denoise value to retain some of the original proportions of that particular frog. Amazing. I absolutely love these explorations. I don't know, because I feel I'm part of the process, and I'm not just like typing a prompt and getting output and be like, oh, this is amazing. And this particular output is a little bit different, where I reduced the ControlNet a lot and kept the denoise more. So that's why you will see the designs are not really same. Their position keeps shifting because the ControlNet is reduced substantially. Apart from that, another time when I use denoise value is, let's say now this is a design that I did. I first rendered this in Twinmotion. Then I used ControlNet, and in this case I used a denoise of 0.9 to retain some of the original material. I think it was 0.9 to 0.95. And then I prompted it into like various materials, various time of the day and things like that. But on the contrary, when you just have a image, when you just have a white image or it's a render from any 3D modeling tool, do not use a denoise value. Otherwise you will see the edges being white. For example, in this case, I didn't use 0. The denoise is 1 basically. And then I just prompted it, and then you get these output. So do not use denoise when you have a white background. Only use denoise when you have a proper composed image, or when you take a photograph. Now in this case, I used a little bit of denoise value just to give you, this was in rainy season and this garden in my house was looking really nice. So I took an image of it and was wondering what would a city look like when I take this image. So I converted this into only depth map, not even canny, and then converted this into like how would a city look like, and looks amazing with different it could be island, it could be made of mud in different seasons. Really, you can go bonkers with whatever prompt you want to do. And I like to do that. I like to take an image that is real and fuse it with AI to get something that's very unimaginable, let's say. In this case, I took image of this hibiscus flower. Again, I took a depth map of it and converted that into a build space. It's not really that great, but kind of showcases the idea. This in the winter looks really, really nice. Okay, so this is what you can do with just ControlNet. Can keep changing the prompt. For example, now I kept the same prompt here for all of this. Aerial view of a wooden pebble in the jungle. And now I just wanted to change the seasons. So in the spring season, it looks like this. In the rainy season, you just kind of get like a water body. In autumn, it kind of changes the weather, and in winter, it kind of adds in the snow. For all of these, the seed is same. So that's why you are seeing some of them with the cutout and some of them with not cutout. You can also change the seed. You can also for all of these, everything is same. Only the prompt is changed. So in the end, I wrote in the spring season, in the autumn, and things like that. You can change during the time of the day. So it could be during dawn, during noon, during a golden hour, or in the night. Now, for the night image, because the image was fully white, it couldn't kind of do it for the top and the bottom. But if your image is already fully done, it will do it. Then you can change the lighting. Now here I put volumetric lighting, firelight. See, you get this crazy like fire going on. Then there is neon light, LED light around the pavilion. Then you can change the material. You can make it metal. This is absolutely stunning. I love it. Then you can make it concrete, glass. This is also amazing. Or stone. The imagination is left to you. Or you can change it in the context. For example, I then add it in on moon with some astronauts, and this is crazy good. Then on Mars, the same prompt, just change the location from moon to Mars, then desert, and then mountains. Here I added things like on top of a mountain surrounding by a fog, basically describing the environment. So the limitations of ControlNet are endless. You just have to go for it. Okay. Now, I also wanted to compare this with some tools. For example, Midjourney has this feature called retexture, which in essence does the same part. So in the backend, they're doing the same thing. Whatever you make an image, they add a ControlNet and you get a variation of that image. So let's see this particular video, which I was like, okay, I want to compare this. So this first two image, both of them are done in Midjourney only. And then the below one is from HDXL model. And then now you see this, I told it to make it in during winter, and the second one. But Midjourney, you will see, has added a car here, which was not there. So if you want a little bit of if you're okay with not having 100% precision, go with Midjourney. It's faster. But if you want 100% precision of what you want, then go with ControlNet. Of course, with Control, you can be more creative because you have more parameters as well. If I play this further, now this one is, I think, in rainy season. So you will see that Midjourney has added this kind of a building below, but HDXL has followed the image throughout. In the next one, it does add, and this one is in autumn season. Amazing. This is so beautiful. I can't express, seeing so many images online on a daily basis with AI, you tend to feel like it's same, but creating some images like this, it just touches me. Anyway, too emotional about it. And then add it in Mars. So again, if you want 100% precision, go with HDXL. If you want a little bit of a creative change to the image, go with Midjourney. Okay. Then few days back, or rather on May 29th, this bomb was dropped, which is called as Flux Kontext Pro model. Okay, now this works with the ComfyUI, and I was wondering, do we actually need ControlNet? Because this works with instructions. So let's say you make a render, you say it, make this render into night, it will do it. Okay, so I was like, do we really need ControlNet now? Okay, as of now, this is in ComfyUI, it goes through API. So per image charges around $0.05 or in 3.5 Indian rupees. And you need to only give it instructions. For example, render this pavilion on a rainy evening in the jungle, keeping the pavilion design intact, use bright lighting. You only need to give it instructions. It's kind of like the image generation in ChatGPT. But I was wondering, is ControlNet redundant? And I don't think so, because this does things precise and is not creative. I will show you why. So with the same image, for example, this was the input image, and in the middle one is from the HDXL output, and this is Flux Kontext Pro. Now with Flux Kontext Pro, you will see it is done almost the same, but it lacks that oomph. It lacks that ultra realism, especially when you're converting a sketch into a render. If you're just giving it an image which is already amazing, it will do a good job. But if you want a first iteration of it, I still feel ControlNet is the better option. Or in this case, for this particular kitchen interior, I changed this prompt, and the prompts are same for both of them. In HDXL, you have to tell them what you want it. Here you are telling the instructions for like change it in certain way. And with HDXL, you see it's added its own kind of shadows and things like that, which I generally appreciate. Whereas Kontext Pro follows instructions through and through. But here you will see the cabinets in the first image are this black color. Now it has maintained the cabinets and kind of made it in silver color. Of course, I could have given it a next instruction saying that change the silver cabinet into wood. This is just the first instruction that I gave it. But I think it's still really, really good. And for just $0.04, where all of these other AI apps are charging a bomb, this is going to change the world. This is going to change the space of Gen AI. I need to explore this more. If you want me to explore this more and give you more prompts and what it can do, please you can feel free to comment and I can make a video on this model as well. Then I tried it for the same car example, and you see it does as precise as the input image. Its output is super precise. It just kind of made it into this colorful image, but I generally prefer HDXL output because it is more creative. If you want precision, now what am I saying right now? I was saying precision, you go to HDXL. Now I'm saying for precision, go to Kontext. Things keep changing with the AI. It's absolutely ridiculous. Okay. Then I tried it for this suit example as well. So this was the input. I told it to make it a white suit, and this is from HDXL, and this is with Kontext Pro. I think it's kind of similar, very similar in comparison. But the difference is here you have 100% creative control with HDXL. Here it is only instructions. And then for the same watch example, which is like adding this thunder lightning, here it is also changed the atmosphere of the image because I couldn't find how to mask it. I need to explore this further. And then in one aspect which Kontext Pro lacks is the denoise value, because it will only take the instruction. I tried it multiple times. It could not. So you see, it has converted this image into this, and it has just added this kind of a glass aesthetic to this particular mountain, but not really converted it into an architectural space. Whereas with HDXL, because I have 100% control, I can tweak it the way I want it. So this is where I think HDXL will be really helpful. But once, let's say I make this particular model and I want to say that, okay, make this water body into green, then I can use Kontext Pro. Okay, I have to explore this. And then I was like, okay, let's see its capabilities for consistency. Okay, I've become big again. I have come back. That means it's the end of the presentation. It has been a long video, but that's why I should name this as a masterclass on ControlNet. And then I made this video where like I took screenshots from Rhino and then converted each of them into these outputs. And while the output is really consistent, it doesn't follow the scale. For example, here you see the human figures are here, and whereas each leaf is so big. So that's something that I need to figure out as well. But mostly that's it for understanding ControlNet. It is immensely good, gives you a lot of power, and I think you should use it the way you feel right. So I hope you like this video. Do everything that YouTube generally recommends, which is like, comment, share, subscribe, and I will see you in the next one. Thank you.